afternoon, everybody. This is Mr. Tam here from the Thinker's Cap Education. Okay, in today's lesson, we're going to explore methods on how to solve quadratic inequalities, which is a topic that's usually taught in A Math during Sec 3. Okay, let's look at two examples to illustrate how we solve a quadratic inequality question. Okay, let's look at a very simple example here. Okay, x squared minus plus 3x plus 2 more than 0. Okay, in this case, we have a quadratic expression which is more than 0. So in order to solve this quadratic inequality, first of all, we must first try to factorize this quadratic expression over here. And by factorizing, I will get x plus 2 and x plus 1, okay, more than 0. Okay, in this case, after we have factorized it, okay, we need to draw a quadratic curve, okay, to find out where are the parts that are more than 0. Okay, so in this case, I have a quadratic curve which is a smile because my coefficient of x squared is positive. Alright, and the two critical points are minus 1 and minus 2 because these are the 2 points where the curve cuts the x-axis. Right, so in this case, we are looking for the areas that are more than 0, which is above the x-axis. So I'm looking at this region and this region as well. Okay, so to satisfy this inequality, my x would be more than minus 1 or my x would be less than minus 2. Okay, we look at another example which is slightly different. Alright, okay, in this case I have another quadratic inequality where besides x I have another unknown here, m. Okay, so in this case I'm not able to factorize this quadratic expression because I've got two unknowns here. Okay, but instead I know that this is actually a curve, okay, where the curve is supposed to be above the x-axis. So a U-shaped curve because my coefficient of x squared is more than 1. So I have a series of U-shaped curves here, right? Okay, and this is my x-axis. Okay, for the curve to be entirely above 0, it means that there is no intersection between the curve and the x-axis. Okay, which means that my discriminant must be less than 0. Okay, because there is no intersection with x-axis. Alright? Okay, this is the part that students need to understand why discriminant is less than 0. Okay, simply because my curve has got no solution as there is no intersection. Alright, so my discriminant is actually defined as b squared minus 4ac. Okay, my b is actually 3m squared minus 4, 1 and 2m, okay, less than 0. Alright, so solving this inequality, I've got to do my expansion. 9m squared minus 8m less than 0, and I do a factorization from here. I factorize my m here. I have 9m minus 8, okay, less than 0. Okay, again, I have got to draw a quadratic curve, okay, to find out where are the areas that are below 0, right? So in this case, I have a smile again because my m squared is actually another quadratic curve with a positive coefficient, right? So drawing a smile curve, my critical values will be 0 and 8 over 9. Alright, and I'm looking for the region, okay, that is less than 0, and therefore this is the region that satisfies the inequality here, and therefore my m is between 0 and 8 over 9. Okay, I hope that this explanation has allowed you to get a better understanding on when do you use a discriminant and when do you just solve it, okay, by direct factorization and identifying the areas that are above or below the x-axis. Okay, if you are interested in finding out more about our math lessons, okay, please visit the link below, okay, and I'll see you on the other side. Thank you.